Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Hi everyone, welcome to the ETAS podcast. My name is Carina, and I think last time you heard me as a host for an episode was quite a while ago. So I'm really happy to be back. I am the head of professional security services for the ETAS security department, and I'm really excited today to talk about our new software-defined vehicle security paper. So for today, I invited the two authors of this white paper, which are Moritz Minzlaff and Michael Lueke. So welcome, Moritz and Michael. I would ask you to introduce yourself, maybe. I think you can do it better than I can. So maybe, Moritz, do you want to start?
Sure. Thanks, Carina, and great to be here on the podcast. So I'm also with ETAS. I'm actually also with you in the management team for the professional security services, with my focus being on the portfolio. And I've gone before that through quite a number of different stages with ETAS and professional security services, working out of our German offices in Munich, Berlin, but also working out of our North American offices and in Asia, and have seen quite a share of different customers and types of companies and organizations in the automotive industry, and helping them along on cybersecurity matters.
Thanks, Moritz. And then we have Michael. Welcome as well.
Yeah, hi Carina. Nice to be here. So I'm with ETAS from, 2016 onwards. Started as program manager, and now I'm owning a role in the lean portfolio management department, taking care about business development. And it's a great opportunity to be here and share the insights from cybersecurity for the software-defined vehicle. My profession actually reaches back a bit longer than just 2016, of course. So originally coming from the software industry and had roles as program manager and testing lead and global tester there. So I'm quite experienced in the context of software development.
Thanks. So I have the two right experts here to talk about the software-defined vehicle security. I would like to start with a very basic introduction to the white paper and also what the setting is. Of course, I read it, and everyone from our listeners who are interested or haven't read it yet, please go to our website, and then you can find the download file there to read it yourself. The title is about the security for the software-defined vehicle. So maybe you can tell me, what is the software-defined vehicle and why do we have to write a dedicated security paper about it?
So the change that we share and that we see in the context of our white paper is actually the transition that the automotive industry is going through in the broader change of their architecture and the way how they deal with software development processes, and the stuff that comes along with it, meaning collaboration with different vendors and interacting with different players in this field of software development. Because traditionally, the software industry and the automotive industry do not have this strong common space. They have shared activities like Android Auto or Apple CarPlay, stuff like that, but not necessarily a strong common space where they interact in order to achieve something together. But now, with the upcoming challenges of more and more ECUs in the cars, more and more cabling and complexity that adds on top of this, the automotive industry is actually trying to find a way to overcome the situation with different sorts of architectures. And alongside with the change in architecture, we have a change in the way how software is developed. And this introduces new challenges because software is more interconnected, software is actually becoming a more essential part of the overall ecosystem. And this introduces new ways of how to deal with software. But it also introduces completely new build chains and testing procedures and development chains. And here you need to have a special look at the security.
And you can see already the impacts, right? So we've seen that software vulnerabilities have led to safety recalls. We have seen in recent years automotive-specific regulations mandating security in Europe, in Japan, and some other large markets. You see that cybersecurity more and more ranks among the top and the highest business risk. Yeah, and these are then the symptoms that you see because of all the changes and the trends that Michael just mentioned. So it's important, this white paper, because automotive software and automotive security are now very closely linked, and to be good in one or the other, you need to understand both sides.
Okay, thank you. Thank you for that. So that sounds like a big challenge the automotive industry is facing. In our white paper, or you actually, broke it down in a couple of dimensions and a couple of steps. So to maybe break down this whole problem of software-defined vehicle and new software development processes and new challenges in security, maybe we can follow these steps like a salami tactic, face the small problem and then bring it together to solve the actual bigger problem. So from my understanding, the first challenge that we face here is that we have a more complex software. So Michael already mentioned that it's not only the embedded software today, but we have a supply chain, we have a merger from the classical IT software industry and the automotive industry. Can you maybe elaborate a little bit more on how these worlds come together, or what are the challenges and maybe which additional worlds will enter the automotive industry?
So maybe a good starting point is to think about how the data flow in a software-defined vehicle will change in order to allow customers to have a richer customer experience or user experience. The interaction that you will see in cars in the near future, you see them right now already partly, but this will intensify in the near future, where data is actually coming from backend systems and representing, sharing or presenting information in the user interface of the car in order to actually allow a richer user experience in the car, is something that will intensify because it is not only possible to do this for entertainment, but you can do this for all sorts of data streams that actually enrich the user experience. And this is a direction the automotive industry is heading towards, because they want to allow these richer user experiences and they want to make this part of their value stream, right? So when you think about that, the data is not only existing purely in the car anymore. So there is data coming from backend systems. Then you immediately can recognize that this data needs to be transferred, it needs to be handled properly, it needs to be stored. But you also have the needs to create an environment where this data can actually flow. So it has to be transferred in either one or the other way. And along this, you can see a lot of different changes because this is something that is not naturally connected to a car, because the car usually has this onboard entertainment interface. And then you have your mobile phone as, for example, a multimedia stream device that transfers audio or whatsoever. So when you break this down into what other data streams can be enabled, for example, for ECUs, in order to improve the driving experience or whatsoever, then you immediately see that, oh my God, this data needs to be handled in the same way, and it needs to be treated differently than what the development processes for classical ECUs were heading for. And along this, you can also see that you have different development techniques because cloud technology becomes a prominent factor in this context. And then you have different deployment chains that you need to satisfy because you deploy differently in the cloud than you deploy something or software into an ECU, and so on and so on. So there is a whole tail of changes that actually enable this change of data flow inside the car. And this extends not only for the software itself, it actually extends also to the whole ecosystem, because you also get other vendors that try to, let's say, find their spot in the automotive ecosystem. So along with newer techniques for software development or change techniques in software development from an automotive perspective and an increase in the ecosystem, you have this software also growing over time. And this is the cube that we actually talk about in our white paper, where we say software itself in the automotive ecosystem is growing along these three paths. So we have ecosystem, we have timeline, and we have the supply chain. And the cube that is growing exponentially because you have more ecosystem that you have to satisfy, you have a larger supply chain that you need to consider, and this all spans across the ever-growing timeframe.
Yeah, so we like to summarize these in a way and say that the software-defined vehicles challenges a number of assumptions that previously were true, right? So you mentioned data flows and backend systems. So we like to say that the software-defined vehicle challenges the onboard-offboard boundary. So it's what previously was the physical vehicle, and this was the center of attention. It's now a much broader scope, right? It's also challenging the understanding of or the definition of what it means to be automotive software, right? So similar to how your Windows laptop runs very different software than your, 20-year-old washing machine. We have a similar situation now coming in with all the different technologies and devices you already mentioned, Michael. Yeah? So it's challenging the onboard-offboard boundary. It's challenging assumptions about automotive software, and with this also how you develop that kind of software. And as one example, so what we do with customers sometimes is to trace, or what I can recommend as an exercise, to really trace in detail all the sensitive kind of data that you have to and from a vehicle and all the different systems it touches. So you have backend systems, yeah, but you have OEM backend systems, you have supplier backend systems, you have third-party backend systems, you have the development centers, you have the plants involved in there, you have repair shops, you have smart devices, you've got the energy grid, you name it, and to really trace it. And this can be a really enlightening exercise to see who touches what kind of data, and it can be quite enlightening.
Okay, yeah, wow, that sounds like a very complex problem to solve. And with the complexity, I can imagine also the security risk increases. I probably think it would be a very interesting different podcast episode to talk about how to actually develop the software. But since we are from the security department, I want to dig a little bit into how do we secure this huge mess, I would call it. So right now, I understood from what you said, we have a bigger supply chain, we have a bigger ecosystem, maybe not bigger, but with not so clear boundaries between each systems. We have the time frame and the continuous software updates that you mentioned. So with all of these complexity in these three dimensions of the cube, how are we going to secure that, or what can we do to at least start coming up with a plan to secure that?
That's an excellent question. So when you want to have the software secure and bulletproof, so that nobody can actually mess around with it, I have bad news for you. This is not going to happen.
Too bad.
It's a bit sad, but that's the way it is, right? Software development at that level always comes with a challenge that it's constantly changing, right? I mean, that's the nature of the business of software development, that you actually have the flexibility to change things, and you're not having a gear wheel that is fixed once it has been created. Software lives by the change. So the methods that we need to apply if we want to deal with risks in this context, and that's what we are mainly talking about, we talk about how to mitigate risks in the software development process, is first of all human oversight. So you have to be clever in choosing your sources, but you also have to automate as much as you can. That means since you cannot have oversight over all the elements, you need to have clever systems that help you to identify where the risks are coming from and what are the highest risks in this context. I mean, in the software development context, we have CVEs and stuff like this for a very long time now. And a similar system is something that is becoming more and more visible in this context, which is a software bill of material that actually helps the industry at least to identify which components are part of the overall supply chain they are using, right? So once you know what is in your software, you can actually implement systems that can start verify if there are any vulnerabilities existing for these solutions. However, testing and especially automated testing, including vulnerability testing and pen testing, are also essential parts of this game. You need to be constantly aware, and you need to constantly test and pen test your software in order to ensure that functional changes, improvements, or bug fixes do not introduce new, let's say, holes in the protection framework, right? And clear visibility to these vulnerabilities and then setting priorities is most probably the best possible approach. And this all comes down together to one aspect, which is speed. Yeah. In the whole development process, being fast when it comes to fixing a zero-day exploit is the key to actually mitigate the overall risk situation in the best possible way. If you have a software development that can actually release a fix patch within 4 hours after a severe vulnerability becomes visible, then you are at very good side in order to protect you, your business case, and your customers. But when it takes you much longer, if you have vulnerabilities open for days or even weeks, then for for the future of the automotive business, this can be really, really a challenging, if not even drastic problem. Because if an attacker can exploit 0 days for a very long time, he can do really bad things. I mean, tearing down whole fleets or whatsoever. Is certainly one of the aspects we're talking about here.
Yeah, so what I like and very much agree with Michael is how you talk less about a fixed, I don't know, technical piece of solution that we now build in cars, and you talk a lot about organizational capabilities, organizational culture, and the approach of how to do software development. You mentioned speed, because to come back to the picture, Carina, that you painted of that three-dimensional risk space with the 3 dimensions of time frame, supply chain, and ecosystem. This risk space is expanding continuously in all of these dimensions. So whatever you build in now into technically, these are still meaningful and necessary steps. Yeah, we still will need this secure HSM firmware. We still need to protect onboard communication and so on. But this risk space keeps growing, so we very much need to also look at the organizational capabilities, like you just mentioned, to keep up with that pace. Speed is the word you used, Michael. So I very much agree with this, and I think this is a a big change, or the acceleration of this expansion is one of the big changes with the introduction of the software-defined vehicle.
Moritz, I'm not sure if you said big change or epic change, but I think both terms are true. So I think we're facing something really great here. Um, so what I get from your answers is it all comes down to we need more automation, we need to be a little bit more organized to keep an eye on and an overview on all of the complexity, and we need to be flexible enough to change our software and to adapt all these solutions, which could be summarized to we need more speed. Um, the automotive industry, as of today, is not very famous for their speed, I guess. I mean, we have very long development time frames from the past. The development of an ECU is probably 3 years, around 3 years. So I think this will be a very huge challenge to fulfill the needs and the processes we have from the past, which are still valuable and necessary for the future when I think about safety processes and stuff like that, but to adapt them from what they have been to a more flexible and faster approach. Because I can imagine the automotive industry is not starting on a green field, right? We have a lot of legacy systems, so we cannot just stop doing what we did and then start something new. So I guess there will be an evolution of from classic architectures to an SDV architecture. And with that, I would be interested in what you think, how we can apply the well-known solutions and methods we already have to be SDV ready. So Moritz mentioned we still need HSM firmwares, we still need the classic solutions. I think probably also something like secure boot, secure trust, secure flashing. Everyone heard about it. So how can we use the principles we know already today and transfer them to the SDV? And maybe to make this whole question more round, what are the principles we have today and how can we transfer them to an SDV context?
Yeah, so you mentioned the security principles, and I was thinking of them already when you explained your question, Carina. Yeah, so we've broken down this complexity of this three-dimensional risk space into four principles, and how they need to be rethought, let's say, to apply to the software-defined vehicle. The principles themselves are not new in the security space. So we have security by design, where you think also a lot about processes, how you develop, how you maintain security. Defense and depth, which in our view also means thinking a lot about the technology that you're using. You mentioned secure firmwares, you mentioned secure boot, secure flash, and so on. The principle of doing risk management, continuous monitoring or monitoring to begin with. Here we look primarily on information. And then, of course, organizational security management. I mentioned how in this episode of the podcast, we talk a lot about people, organizational capabilities, culture. So we've got these four principles, and they're not new in the security space. But what we need to do to be adequately secure and to adequately respond to this growing risk space, this is new, and there's some changes. And maybe Michael, you wanna explain or start off and explain how some of these needs to change.
Yeah, absolutely. Thank you. So when, for example, if you look at the security in depth, there are different aspects when you see ECU, plain ECU development compared to developing software for SOC. Why is that? Because the ECU itself has a specific functional set, and that is limited to the one particular function space it works in. But with the change in architecture, the rise of SOC will bring a mixture of these functional aspects into one single chip, into one die. And even though there are trusted execution environments within an SoC, you clearly have to make sure that it's not only the execution space within the SoC is secured, you also have to ensure the security and integrity along the whole supply chain for the software that actually runs in this SoC, right? And when you think about what that means for security, and that it means that you somehow have to protect the source code at the point in time when it's created, when it is going to run in an SoC context. Because if somebody can exploit your source code, he will be definitely able to exploit also the function space in your SoC. And this is what you want to prevent. So when we look at the way how software development is impacted, we can clearly say it has to become more integrity protected, because attacks on the software supply chain are becoming more prominent and more visible in the last years. And for the increasing use space of SoCs in the automotive ecosystem, it is getting more and more attractive for attackers to actually see this and make this a vulnerable space. So attacking software supply chains in this context is a critical aspect. So the protection needs to extend to that space as well. This is, for example, one change that we see, and there are many more, but we cannot actually talk about all of them because it would take too much time.
Yeah, maybe another one that I would like to highlight, that we've seen also quite often from the professional security services and the consulting services that we offer, how the organization needs to change its mindset. You have basically a change project on your hands, where you go from maybe a checklist mentality where the organization is compliance focused, and you have, okay, I built in this technology, and then I'm good. Where this needs to change to a security mindset that incorporates all stakeholders within the organization and within the supply chain and within its ecosystem, right? So you mentioned how the data flows into many different segments of the ecosystem, how complex it is. And here you have many different stakeholders that need to be taken into account. And security from a developer's perspective, for example, is different, or what risk is to a developer is or might be something very different to what it is to a product manager, business owner, and yet again something very different to the driver of the actual vehicle. And this is something where we need to have a good consolidation and translation of information so that everyone knows how they can now deal with this maybe changed risk and how to get an appropriate response.
Well, thank you for this elaboration on the principles. I probably think we can fill hours of discussing the principles and how they change for SDV. What I felt when I read through our white paper, I felt a little bit intimidated by all of these complexity, by the changes, by the challenges we are facing, and by the speed that the ecosystem of a car, of a vehicle basically is growing. So I was really happy when I read one comment in there that says the maturity and the steps I have to take towards securing an SDV have to be big enough and fast enough to counteract the growing risk. But on the other side, they cannot be big enough as well, because as we all know, if you have too much security, it costs a lot of money and it can waste resources and just overstretch the organization, so that the acceptance of security might be reduced. I found this very giving me a peace of mind. We have to take steps, and they have to be big enough, but then also we don't have to get from level 1 to level 5 in a month or so. So that was really comforting for me. to know that yes, we have to go on this journey, but we do not have to tackle this huge challenge all at once, but we can do it step by step. Um, for this, I would be interested in how do we get there? So how do we come up with a plan? I mean, we have a lot of things to talk about. Moritz mentioned we also have to change the mindset, and just from own experience, I know changing a mindset can take a long time. But how do we come from the level we are to where we want to be, and what might this be? So do we all have to reach the end level?
It's also a good one. I may start. So the good thing is, no, you don't have to be at level 5, as we see it
Thank God.
under all circumstances, right? So what the industry needs to learn is that it has to move with a different set of paces. There will be the development for traditional ECU will most probably stay the same as it is, and then for SoC-driven architectures, the speed must increase. However, another good aspect that we need to keep in mind is that the industry does not need to reinvent the wheel here when it comes to security. I mean, a lot of security measures have been used in the software industry for ages now. And what the automotive industry can do is they can simply take them and reapply them and use them for the automotive space. Yeah. For example, CI/CD or DevOps philosophy is absolutely nothing new for somebody who works in the software industry. And bringing this philosophy and really living this philosophy and utilizing these techniques also for the software development in the software-defined vehicle context is the key to be successful in here. And you can make this what is also known as shift left in gradual steps. You don't have to make this one big step. You can start where it's easy and then start to also involve the parts of the company where it's maybe more difficult, like quality management or whatsoever, where you really have to look from a different perspective on all of these aspects. Yeah. So the way forward is heavily individual. So every company, so there's not this one big way forward where you can say do this and then you are fine. No, it's heavily individual, and every company needs to find a way that actually supports their value stream, and it's also depending on what they want to do next. So this is something that really needs to focus on the individual characteristics of the department, of the software development group, and of the company.
Yeah, so basically what you can do is and I think this holds true then for all or most organizations, that you look at the status quo, where are you, right? So we've discussed the 4 principles that you take stock. You can do this with an ad hoc questionnaire you develop yourself, or taking all the comments we made today or through the white paper. We also have a very fleshed out and proven maturity model for that, where we can do an organizational assessment. But you can take stock of your status quo. Where are you? Where are you in your own organization? Where are you with respect to your supply chain? And then you mentioned a couple of things, Michael, for the target state. So where do you need to be? And it's not the same for everyone. You have different brand positioning, different risk aversion. You have different target markets that come with maybe additional compliance requirements. You have different products. And out of these 2 endpoints, the status quo and the target state, you can derive your roadmap of what you need to do, and you can take stock of or take into account boundary conditions of the organization. How fast is it moving towards the SDV overall? Yeah, and that of course has an impact how fast you can and need to move with security. And then derive a program like you just said, and like Carina, you can take step by step. It doesn't have to. It's not going to be this one big thing, but it's going to be a permanent adjustment towards your target.
Cool. So I understood we can take it step by step, which is great. So no need to run a marathon. Maybe we start with a 5K instead. I also picked up that Michael said we can take over solutions from other industry, like from the classic IT industry. I think this is a really interesting thought as well, because I think the white paper also touches on this. We should not reinvent the wheel and make mistakes that other industries already did. So taking over and adapting maybe what they already did and what they came up with to the automotive industry needs is a really great way and an easy way to start from and maybe gain improvements without having too big of a problem to solve, because parts of the problem were already solved for us. And then the last step that you mentioned, Moritz, I think is also very important, to define a target that fits to our company or to your company and to your needs, and maybe also business strategy and target markets. So not everyone has to be at level 5 if level 3 or 4 maybe is enough. So I think that's very comforting to know. Thank you for that. I don't have any further questions so far. I think we can dig into way more details here, but this would probably extend this podcast by 4 to 5 hours. So my last question to both of you would be, what is the one recommendation for our listeners that you would recommend for them to take as a next step towards their SDV?
It's actually it's a few steps. So first of all, read our white paper. It really helps to understand the big picture. We really try to not go too deep into the different topics, but to give a good overview and to give some ideas how we can mitigate that. And then when it comes to adopting methods that have been applied in the software industry, like for example zero trust or whatsoever, they can be overwhelming when you think about how you want to apply this in the automotive context. But that doesn't have to be. With some help, it is actually possible to map the different activities and actions that are outlined in such concepts to an automotive ecosystem. You just have to understand the baselines. And this is most probably the point where we can really jump into and can help to translate this complexity between the two worlds smoothly. No?
My last comment will be maybe less of a step and more of a encouragement, because we also do, since a number of years, a yearly survey in the industry of the cyber maturity. And one of the questions we also ask is, okay, so how satisfied are you with the progress you've made since last year? And there's a clear correlation between those companies that make progress and how satisfied they are. And so my point is, get started. Don't be overburdened by this complexity. Don't be anxious. Take the first step. It shows that with the progress, the satisfaction, and in the increase in the program you're following and you want to push through in your organization, that this will come. So really encouragement to take that first step.
Thanks a lot. I think those were really great last words for this episode. So thank you for being my guests, and I hope we can maybe meet again and talk about all of the details we skipped today, because this topic is really complex. And I think both of you were right. Just get started. And if you don't know how, just get help or listen to podcasts, read our white paper to get some inspiration. And I think we have great ideas in the industry how to tackle the SDV challenges. Thanks.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.